So I'd like to know, just a quick raise of hands, who's been affected, like personally, by a security incident or cyber-related incident? No? Okay, good. Everyone's hand should go up if you use social media, of course. So I'm the security lead for the well-architected framework inside of AWS, and we had Jason present on it a little bit earlier, and we'll be going through a lot of content. It's a reasonably technical session, so I've got a bit of CLI, a bit of services, and stepping through some different areas. And I'm stepping through ultra quick because my clicker won't go back to my agenda. Alexa. There we go. So we're going to go through how to start your incident response journey. If you're mature, then how you can improve it. An insider threat, so based on credentials that have been outside of the organisation and are going to be reattempted to be used. And also how can we respond to an incident and run some really basic forensics on an EC2 instance. So I'm going to go through this session as Bob. I won't be Bob, but I'll talk about Bob. Bob works for a startup. They're very, very immature around incident response because it's all about getting their product out first, right? So Bob's responsibilities is he's the DevOps lead for security in his tribe. So he owns security. He's the only one. They don't have a CISO. They don't have any of that. Okay, so he's everything. He's the first level responder, and he needs to escalate up to management and bring in other partners to help if they have any issues. So I'm going to share the two interesting experiences for Bob, how he's dealt with a rogue employee that's been terminated and left the company. Her name's Trudy. Yes, it's Alice and Bob's Trudy the intruder. And also how he deals with an instance compromise and how we can automatically isolate that instance and run some basic forensics on it. And this session is going to be all about tooling and how we can automate that. So in terms of where to start is if you have no incident response processes at all, a bit like Bob's organisation, you can start with the NIST 800-61, the Computer Security Incident Handling Guide. It doesn't even mention the word cloud once, but it's all about how you form your teams and how you can respond and process working through an actual incident, all the way through to post-incident activity, how you can recover after the response. Number of resources, you're welcome to take a photo of these. If you scan your badge on the way out, you'll actually get a copy of the slide deck as well. So we have the Security Centre at the top there. In the middle is the team that I work for, the well-architected team, and which you can download the white papers and get some really good guidance and advice on how to architect cloud workloads. And the last one there is a YouTube video on incident response in the cloud from last year's reInvent conference. The top one there is using Lambda as your security team. So everyone knows AWS Lambda. If you use Lambda as your security team, it can help automate. So poor old Bob, he's the only person in security, right, in his organisation. So he really needs to leverage the tools and automation, as do you all, to try and get ahead of the adversaries. SleuthKit is a file-based forensics toolkit. It's open sourced, used quite widely out there. Is anyone using SleuthKit? Or no? A couple? Okay, great. And open source incident response tool called AWS IR is at the bottom there. That's led by Andrew Krug, a mate of mine in Mozilla. All the code and demos and examples of this we released for the Sydney Summit, and I did a similar presentation at the Sydney Summit, and they're all available on GitHub. And that means you can help improve and contribute to this code that's out there open sourced. So I really appreciate it. So well architected, just to give my team a bit of a plug here. These are the security design principles. What we'll be focusing on today is automating security best practices and preparing for security events. That's being prepared ahead of time before it happens. When I was doing this presentation, I immediately thought we could do a honeypot and then show a honeypot trying to attract people in and then what sort of indicators of compromise come out of that. And I was thinking, nah, it's dangerous, right? Running a honeypot, running a deliberately misconfigured system is very dangerous. The detective capabilities that that are in AWS allow us to trigger automation and different indicators off of that instead. So we don't need to go to the extent of creating a honeypot just to attract attackers. So what we want to look for is potential indicators of compromise here. So we've got denies in CloudTrail, and that's what my first demo is going to be all about. Denies to access Amazon S3 buckets. Now here's a little tip. You could actually have an AWS account that's isolated from everything else. You could create your company's name or your particular project's name and have different bucket names that you can then use as canaries. So if anyone's trying to scan your bucket namespace, they might go after your actual company or project's name or agency's name. Also, denies in VPC flow logs. So from the outside in, you're going to get a lot. There's a lot of noise out there on the internet. From the inside out, though, why is this instance trying to connect to SSH in Korea? You know, something like that. That's a definite indicator of compromise. Also, abnormal behavior. And the last one's very difficult to pick up in logs and just see a deny in a log. And this is where running a security incident event management system or a SIEM and turning on services like GuardDuty can really help you with that abnormal behavior detection. So this session assumes that you've already turned on everything and the demonstrations. So CloudTrail's turned on, GuardDuty, config, you've got all those detective controls already there in place. Also, another best practice is logging application and system logs into CloudWatch logs, because the same triggers that I'm going to show you in the demos can be applied to your application level logs as well. And I've started the most likely scenarios. In our case, we're a startup. We've got a lot of turnover. Bob's startup, sorry, not my startup. And that's what we're going to go through an insider threat. So this is how I'm going to detect Trudy, the intruder who's left the organization. We want to be notified of any access denied attempts that she's made or anyone else has made from the outside. We want to know who's attempted what and from where, and by where I mean an IP address, the user or the role that was denied, what is she actually or somebody else out there trying to use, and what the history of that user or the role has done in the past. So we can start to build up this knowledge to give some information behind a potential incident. So we can make a decision, is this real or is it just noise that's out there? So this is the access denied responder that's out there in GitHub that I'll be doing a quick demo of. We've got CloudTrail logs, all the API activity in an AWS account. We have a CloudWatch event that triggers an SNS topic that is then subscribed to by a number of Lambda functions. So these Lambda functions do the publish to a Slack or Chime channel. So we can get all of this information within a few seconds of the actual access denied attempt being made. And we can look up the IP addresses through a Whois service. The XML Whois service is the one that we've used in this example. So we can get all of that information really, really quickly. This is what a Slack notification looks like. So we've got the account number. You can see there, this is Trudy-backdoor is the IAM user. Okay, it's pretty obvious that she's called it backdoor, but it might not be that obvious. We've got all the user agent details, the IP address, and down the bottom there, we've got the history of what that user has done in the past. But I'll show you in the actual demo, which we'll flick over to. So, I've got a console. I've got my backdoor Trudy user. Just going to use, let's use ASDF now. And we've got an access denied. Okay? Now, this is interesting because somebody to do this and to get this particular deny in your account means that somebody needs to know the username or the user in IAM or the role as well as your account ID. So this is where this scenario is really good for an insider threat, because an insider or somebody that you've worked with before, or in my case, presenting to a few people and putting the actual account ID. I actually use this same account at Sydney Summit and it just gets slammed. It's hilarious. It's so funny. They need to know that, right? So then you don't get the noise of somebody just trying to do the wrong thing inside your organization. Like, oops, I clicked that button, I wasn't allowed to do that, and you get a deny. This is like deliberate attempts to try and bypass your security. So this is where all the magic happens. I won't show you in detail of what goes on with the SNS and that, but this is basically the Lambda function. You'll notice a little warning up here. This function belongs to the CloudFormation stack blah. Use CloudFormation to manage this Lambda function. So the CloudFormation template is provided in the GitHub repo for you. And of course, best practices to automate security best practices and also use code, and we want to use infrastructure as code. That's why we use CloudFormation. So just zoom in. So I'm not going to go through it in detail, but you can see we've got the event source, so it gets the IP address. It does the geolocation lookup, and we've got the history. This is where it posts the message and the history for the user, and so on. And this is where we do the whois lookup. Cool. Now, if I go over to Slack, we've got two parts to it. So we've got security alert there, we've got access denied event from backdoor, we've got the actual, my real source IP right now, and we've got the history of who's performed what on that IAM user in the past. So if I saw this was Trudy or somebody who had left performing these actions on this particular IAM user, like in this case, I disabled some access keys, and Byron down the bottom there created them earlier in the year. So I've got that clear picture of who's actually touched that IAM user in the past. And then down the bottom there, the history for the user, the recent API actions of what the user has done, my IP address details for accessing that. Cool. Now, this is IAM, and IAM's obviously just one area of indicators of compromise. And I get asked by a lot of customers, like, where can we find the list of all the indicators of compromise, all these indicators that we can configure? What alerting should we do? Well, guard duty. And in the guard duty docs, it has exactly what it looks for. So then you can think, actually, one of the guard duty is actually user permissions and anomalous behavior for IAM users. So then you can think, you can take these as different scenarios and then run through how you're going to respond to these certain detection events within guard duty. And then if you're hopefully using a SIEM, then align them up to what the SIEM detects. So you have that correlated picture of what detective controls you have and how you're going to respond to that event. And hopefully it's not an incident. Cool. Let's flick back to the slides. Alexa, thank you. So security automation in this case was awesome. It didn't actually break anything for once. But I need to think of how I can improve. So I want to go through that list of all the detection findings that guard duty has as a starting point, and then think about how that applies to my organization. What's the most likely scenario? Do I have an offshore dev team? Is it actually code leaving or the turnover of employees in that contractor? Yeah, I think we pwned the ex-employee as well. She probably shouldn't use backdoor as her username. Okay. So next up is how we're going to automate the isolation and what I'd like to call a clean room of an EC2 instance that's part of an auto-scaling group. It's in a web or application fleet. How we're going to isolate it, snapshot the volumes, and run some basic investigation. So you got to bear with me here. There's a bit to it. So we start off with an SNS topic, and we take in the instance ID. This means we can use guard duty, or you can use your own SIEM or your own tooling. You could even manually just send an SNS notification with the instance ID. Pretty easy. We're going to then verify the instance exists and it's not tagged inappropriately, like do not touch. Then we're going to start off the step function, which is our coordinator for all the other Lambda functions in here. So the first set of Lambda functions, and there are a few in this, is remove it from auto-scaling. And it has some logic in there. Like it can't be the last instance in the auto-scaling group. We're going to then snapshot all of the volumes at that point in time that are attached. We're also going to then record all the EC2 metadata. So what was the launch time, what AMI was it launched from, all the data around surrounding that instance, IP addresses. We're going to apply tagging to say that it's under investigation. And then finally, we're going to notify through Slack, through SNS. Of course, you can plug in your own notification APIs in there, that this instance has been isolated. We've had a security event. It's under investigation. Next up, we're going to isolate by using a security group with no ingress and no egress. The reason why we're not terminating at this point in time is because we're not forensic experts. We want to leave that there unless it's really doing some damage, so we can go and later investigate it. So while it's disconnected from the network, you might argue that it can't actually do any damage. We're going to then use CloudFormation to create a clean room, completely isolated VPC in the account, and then run some basic forensics using the disk-based forensics in the sleuth kit. We're going to then generate some reports. The example reporting that's in the GitHub sample is just based on recent files that have been deleted, because an adversary might think they're being looked at and try and cover their tracks. Of course, this doesn't cover memory-based forensics. So, poor old Bob woke up one morning and saw this. He's had a security incident event detected. It's been isolated, great. It's had, and then it runs through and tells him exactly what's happened in here. And it even says it's been drained from that particular load balancer. So Bob didn't have to be woken up for this. Bob had this all ran for him. And then the next alert, and it takes, depending on the instance size, it takes 5-10 minutes, and the volume sizes to come through. Then he gets a notification of the recently deleted files on the file system. And in this example, it's pretty easy to tell if you look down the bottom, that file name. But if this was a case where you knew what you're looking for, you could look for particular file names in the file system. And of course, you've got a full, I'll go into the demo and I'll talk a bit more about it. Okay. So first up, I'm going to, Alexa, do the demo, please, Alexa. Thank you. She really doesn't listen today. So this is the open source autopsy tool. So what I've got here is a volume. This is the GUI front end for it. So all I've got here is a DD of a Linux instance, and I can go through. It's very similar, if you haven't used it before, to others out there. Obviously, it's not as powerful as something like Ncase, but it gets you there. So I can look for particular things on the file system, like interesting items. I can run hash sets of what to look for. If you've had particular malware out there before in your organization, then you can look for those hashes in there. I won't go into too much detail on that. Interestingly, though, you can get all the email addresses that are referenced in the file system, which I thought was pretty cool. And you can generate this pretty HTML report. And I thought it was pretty cool. I was looking at it before, looking at AU contributors that are in the file system. Go away. And we have someone from Cyro in the actual source code in the instance. Cool. If we go into the step function, this is the actual step function configuration. So we've got a capability there to create a support ticket. So if you use a ticketing or problem management system, then we can create a ticket by an API in that system, and then we can start the instance isolation, go through the notification, the actual preparation for the remediation, all the way through the stack there. As I mentioned, it takes a few Lambda functions to get set up. and they're all in the CloudFormation template. These are all the Lambda functions that's required to get it running. We'll just drill down on one here and we'll have a look at what it's doing. So we've got there, it's starting up the instance and it's getting the user data out, exporting. Cool. So I've spoken a lot about file-based forensics and just having a very quick look at those deleted files in the file system. From a memory forensics perspective, I've got a demo I prepared earlier. So I've got an Ubuntu image running the open source volatility framework for memory-based forensics. And it can do all sorts of cool stuff. Now, if you wanted to run volatility on your own Linux instances, Linux, can't remember what kernel version above, uses randomization of memory address space, and it makes it really, really, really hard, almost impossible, especially for volatility, to run memory forensics of your instances. So volatility has a number of different tools. So PS list is one of them. So we can actually get a process list of all the processes that are running at that point in time where we took that memory sample from the instance. Cool. Let's see what else it can do. Can scan for Windows services. We can see the sockets. So any open sockets that are on the instance at that point in time as well. You notice I'm using a Crydex example memory dump because it's easier to get one from the samples. My favorite's Notepad. No, Notepad wasn't running. So you can actually see what's in Notepad and Clipboard as well at that point in time. And the Sleuth Kit allows you to go in and see in Windows like the alternate data streams as well, where a lot of malware and bad stuff hides in alternate NTFS data streams. That's the Sleuth Kit, so it's just sleuthkit.org. And memory samples, if you want to have a play around with volatility, they are there. And on the previous link that I showed, the open source AWS IR tool on GitHub had the version of volatility that works and a tool for automatically grabbing the snapshots. If we have a look at the file system here as well. So, jumping around. So as I mentioned, we've got the file system snapshot that SleuthKit takes that we store in S3. Here's the output of it on S3. And if I open it up here, here's the full file system, like every single file on the file system for that instance at that point in time. So if I look for that hack file, there it is there, the hacked file. What I could do is run this routinely when I build new Amazon machine images and do a diff. What's the difference between the potentially compromised instance and what I had taken off that base AMI? And that's one step where we want to put into the step function to run that. So automating the next level. Of course, we'd have to remove the common noise out of temporary file systems and that. And here's the output of AWS Systems Manager, actually running that for you, the forensic investigation on the system there. Cool. Right, let's switch back to the presentation now. Thank you. So what we did is we've run some, okay, it's very rudimentary, very basic forensics, but we can extend upon it, right? We've got the step function there, we've got the Lambda functions, we can grow. But no person, Bob didn't have to be involved in this process. So not only did it save him getting out of bed, but it could have saved us from a worse or more widespread incident. We automatically got all that information through. In both examples we did. And as I mentioned with the AMI diff we can do on the file system, we know what the difference of good and potentially bad looks like. And again, we can do that for memory as well. What are normal processes that are running on that AMI, running my workload? And the security system doesn't break anything. Cool. Incidents are always really badly timed. They will happen at 3 a.m. Or even worse, they'll happen and then you won't know about them until 9 months later, in the case of many that have been published in the press. So my advice is to really prepare for an incident before it's too late. If you don't have any processes at all, have a look at the NIST guide and where to start. If you have very mature processes, then take a look at the automated tools that I've showed and see how you can integrate them in to your processes. And I like to practice incident response through game days. So run half day or even a couple of hour sessions with the different teams involved, not just the dev and the teams, but everyone involved for running that particular application. I find it really fun in not only the practice, but when I used to deal with incidents in real life. It's like a game, right? It's fun. You're trying to challenge something at the other end. It's really good. So always stay up to date. I love the AWS security blog, as well as Jeff Barr's general AWS blog. And my Twitter handle, LinkedIn, is there if you want to stay in touch. And if you want to find out more and get the slide deck at the end of this session, then please scan your badge on the way out. And with that, I thank everyone for coming. Thank you.